All right, thanks, Heike. Can you hear me okay?
Yeah.
Yeah, okay. Um, Thank you for that introduction. And you've already highlighted on some things that I want to talk about today in terms of some of the connections between Newfoundland and Nova Scotia and Memorial and Dalhousie. And that's something that I'm going to try to, to bring up throughout the seminar today. So this was the first time, I've been doing, I've had this position for 3 years. It's the first time I've sort of had to sit down and pull the research program together in a seminar. So I spent a fair bit of time thinking about the main themes that we research and the stories that I could tell. And, the history and the legacy of fisheries and the cod collapse, obviously here in Newfoundland. And at one point, I was thinking back and, let's see if I can advance my slide here. Okay, here we go. And we had a seminar earlier in this year by the late Jeff Hutchings. And, he gave this seminar via Zoom, but he gave this seminar just 2.5 weeks before he passed suddenly. And I think we were, very surprised to hear the news at the Marine Institute. And, given Jeff's legacy and his work in Newfoundland and speaking to the cod collapse and, the reasons for it. And during this seminar that he gave us, he spoke a lot about, his work that he had done here on northern cod, and particularly in the context of regime shifts. So when thinking about, how I would speak about the seminar today, I thought I would really try to, talk about the work that Jeff had done in the region, and also sort of continue on some of the things that he was thinking about when he gave us the seminar. So the title of the seminar was Disentangling Regime Shifts in Fish Productivity, Atlantic Cod and Atlantic Salmon. And, you could see here that he had shown some of these historical pictures of cod in Newfoundland and, how important that is for the region economically and culturally. Jeff also did his master's and his PhD research in Newfoundland. And the day before he gave us the seminar, he published kind of a perspective piece in the IC Journal of Marine Science that was called Tensions in the Communication of Science Advice on Fish and Fisheries, Northern Cod, Species at Risk, and Sustainable Seafood. And here's a picture of Jeff with Ram at DFO in 1993. So again, I think there are a lot of linkages between Newfoundland and Dalhousie, and Jeff's work embodies this. And I really want to sort of highlight the work that he had done and sort of continue on the line of thinking in terms of, providing advice about how we manage ecosystems in dynamic environments. So, as we think about Newfoundland and the importance of cod, I came into this paper when I was doing my PhD, and I became interested in this historical ecology that, sort of brought Heike and I together at the Oceans Past conference. And this was a book chapter that Ram wrote that actually had the cover page pinned to my little cubicle where I did my PhD in New Zealand, because I thought it was really interesting of how he was combining, different historical data sets and trying to understand the behavior of communities and fisheries through time. So in this book chapter, Ram used a data set of fishing communities in 3 bays in Newfoundland from 1710 to 1833, and he used a bioeconomic theory to predict the pattern of settlement in 3 bays during this period. And he found that fishermen in each of these bays tended to settle when catch rates were greater than 40 quintals, which is 10 metric tons of fresh cod per man, and would emigrate when catch rates were less. So really, this history of cod and fishing in Newfoundland and the Atlantic region in general, it goes back, hundreds of years, and it has really been driving the culture and the community settlement. We also know that this touches in Nova Scotia. So, the Grand Bank schooners that were common throughout the province, would fish from Nova Scotia on the Grand Banks for cod. So here we have Lunenburg, close to where I grew up on the south shore of Nova Scotia. The Bluenose, obviously the famously celebrated ship for never losing a race to the Americas or to the Americans, but it was also, a fishing schooner that would go out on the Grand Banks. And you can see, how many vessels were there employed in that trade. Also, cod is still a mainstay of Newfoundland culture. So here we have Ezekiel, who was over in St. John's a couple months ago for a fishmip workshop that we had. And in order to become an honorary Newfoundlander, you have to kiss the cod. So here's Ezekiel at one of our local establishments, kissing a frozen cod. That kind of looks like a bit like a spotted grouper, but this culture still exists. And there's a saying here in Newfoundland which goes, fish is cod and cod is fish, which just is an indication of how important it is in this region. So Jeff touched on this in his seminar that he gave for us, and obviously spoke about, the expansion by schooners, which would have, been fishing out of Nova Scotia as well, to the age of the stern trawlers, and then, the dramatic decline in catches, and then the subsequent fishing moratorium that took place in 1992, with an estimated decline in stock biomass of more than 95% in 30 years. And this touched, every part of the province. There was more than 20,000 jobs that were lost overnight. A lot of the coastal outport villages shown here on the south coast, dried up and were resettled. So this really had a dramatic effect, not only on the marine ecosystem, but also on the sort of cultural fabric of the province. And you've probably seen these papers if you've gone up the hallway in the biology department, or up the stairwell, sorry. All of the work that Rem had done, a lot of work with Jeff as well, in terms of investigating the reasons for the collapse of this resource that was, sort of deemed to be inexhaustible, and really, calling responsibility for the mismanagement when perhaps, the writing was on the wall in terms of the science indicating that things were not going in a great way. And so people often think about the cod collapse, but let's see if I can get my cursor going here. But they don't often talk about, what happened to the wider ecosystem. So here's some work by Eric Peterson, and I can't get my cursor to work, but I'll just talk you through it. In the top panel here, we're looking at the biomass as surveyed by DFO, and we can see the total community biomass, which declines, through the 80s and into the 90s during the cod collapse. But we can also look at some of the non-commercial species and see that there is a decline in biomass as well. And then in the middle panel, we have cod, halibut, plaice, and redfish. And again, we can see that it wasn't only cod that was declining through this period. We see that other commercial species were also in decline. And then if we look to the bottom plot here, cod biomass is shown in blue, and we see that dramatic decline through the late 80s and into the early 90s. But in the black line, we have an indication of community biomass, which suggests that this was in decline perhaps earlier than the cod collapse. So that there were some warning signs if you looked at more of a community level that perhaps the system was in change. And so typically in the region, when we study the different ecosystems, we typically categorize them into the Grand Banks region, or 3LNO if you are familiar with the NAFO fishing divisions, shown here in green, and then the Newfoundland and Labrador shelf, shown here in pink. And these have been shown to be kind of distinct ecosystem production units, so the species composition differs between them. And typically these are the units that are used when it comes to managing stocks in the region. And so as Heike mentioned, a lot of work that I did while I was at DAL with Heike was trying to understand what role invertebrates have within the ecosystem. And this is a question too that has become more important post-cod collapse. But what was happening with the invertebrates, at this period when the groundfish stocks were declining? And to a large extent, we can't really answer this question because pre-cod collapse, invertebrates typically were not surveyed. So we can see two plots here of research vessel scaled biomass. These are surveys that are done by DFO in the 2J3K region, which is the pink region, and 3LNO region, which is the Grand Banks, the green region. We can see that the total biomass of the system declined in the 2J3K quite dramatically. But taking into account that pre-1995 invertebrates weren't sampled. Also during the period of the cod collapse, the survey methodology changed from the Engels trawl to the Campellan trawl, and they had a different catchability of small fish. So, during a period when there was extreme change in the ecosystem, we also had a change in survey gear. So it becomes challenging to compare pre-collapse and post-collapse when looking at these data sets by virtue of that reason. But we do see that starting in 94, 95, invertebrates were surveyed. So we do have an indication of how the invertebrate biomass has changed through time post-cod collapse. And that was one of the big changes was, following the groundfish collapse in the 90s, the system really shifted to an invertebrate dominated system. And this is documented if you look at the catches through time. So here you can see through, the majority of the 60s, 70s, and 80s that the piscivores, cod, were the dominant volume of the catch. And then post-cod collapse, you can see that the red colors start becoming more important, which are the shellfish. And so we've really seen a shift in fisheries from, groundfish dominated fisheries to invertebrate dominated fisheries. And one thing that's interesting to take into account when thinking about the socioeconomics of these fisheries is that the price for snow crab in 2021, in last year, was $7.36 a pound, whereas cod was only worth 20 to 80 cents a pound, depending on what grade it was. So an order of magnitude more value for the same weight. And in 2021, the shellfish sector represented 62% of total landings, however, 88% of the value. So they were valued at almost $1 billion. So we can really see this kind of disparity and some of the trade-offs that might be considered when these systems shift from groundfish to invertebrates, and if they tend to shift back. And so then the question becomes: are we going to start kissing the crab instead of kissing the cod? Given that this is really the economic powerhouse for the province now. But in Newfoundland, they're a traditional culture, so we typically see that we're still being offered a cod to kiss and not a crab to kiss. So thinking a little bit more about this ecosystem and how it's changed through time, we know the region is highly dynamic. The Labrador Sea is important for global carbon storage. We have the confluence currents, the Labrador Current from the north and the Gulf Stream from the south, which really mix and meet on the Grand Banks. And depending on the strength of the penetration from the Labrador Current and the Gulf Stream, we really kind of are at this interplay of these two major currents. And that really drives a lot of the productivity for the system, but also it makes it highly dynamic and quite variable through time. And Boris and I were just chatting before the seminar, and he said he just read that the Grand Banks experiences 30 or 300 days of fog per year due to this mix of this cold and warm water and cold air and warm air. And another linkage between Memorial and Dalhousie, the Labrador Sea was a recent focus region for our latest NSERC CFREF invited proposal on transforming climate action that you may have heard about. So if we think about this variability from a climate perspective, It's really driven by the North Atlantic Oscillation, or the NAO. So the NAO is a sea level pressure anomaly. And here in the top globe on the top left, we can see a period during the 60s where we had relatively high sea level pressure over the region. And in the 90s, during the period of the cod collapse, we had a negative anomaly, so relatively cold weather over the region. And this affects things such as habitat, bottom habitat, which are important for bottom dwelling species. And the cold intermediate layer is a variable that we commonly look at in terms of available habitat for these species. So we can see during this warm period in the 60s, we have a bottom temperature that's ranging between 2 and 4 degrees Celsius, compared to the habitat in the 1990s, where we have a bottom temperature that could be less than -1 degree zero by this huge area of the cold intermediate layer. So when we start to think about some of the mechanisms that might be affecting these populations through time, it's important to take the environmental and climate habitats into consideration. And so my colleague at DFO here in St. John's, Fred Sear, has developed what's called the Newfoundland Climate Index. And this basically tracks a number of different climate and environmental variables, and it weights them evenly. So sea bottom temperature, sea surface temperature, cold intermediate layer, these would all be considered in this index. And we can see through time that this varies on decadal scales. So during the 60s, we had a warm period. In through the 70s and the 80s and 90s, cooler periods. And then post-cod collapse, we sort of had a fair bit of oscillation, but a few, cold years and warm years. And one thing to note is it seems like the variability of these changes is decreasing through time, whereas historically these were more persistent patterns of warm periods and cold periods, whereas in more recent years, post-cod collapse, it seems like the system is fluctuating more frequently. So kind of building up from the climate environment to the oceanographic conditions, we can look at how primary productivity has changed through time. And here we've got a plot starting in 1999, going till 2006. And this is an aggregate of all the Atlantic region. But if you just focus in on the blues and the greens, those are the values for the Newfoundland and Labrador shelves. And we can see over time a general decline in primary productivity post-cod collapse, so starting around 1999 in this plot. We've also seen changes in the zooplankton community, so a decline in abundance of Calamus finmarchicus, which is kind of the big juicy zooplankton that's often called the cheeseburger of the zooplankton community, and increases in non-copepods. So we can start to see that these changes in the climate and the oceanography are going to feed up through the food web and have impacts on the higher trophic levels. We've also seen dramatic declines in abundance of capelin from the period of the cod collapse into recent years. And we haven't really seen these massive recruitment events that typically would have been quite common pre-cod collapse. I will note here that the data for capelin, they're hard to survey due to their pelagic nature, so they're not really sampled well in the multi-species bottom trawl. So we use these spring acoustic surveys, so it's not an exact translation, but by all indications, we haven't seen these abundances of capelin, which is one of the key forage species that we used to see historically. And so it's been shown that there is evidence of bottom-up regulation in this system. This is work that's done by Paul Regular at DFO here in Newfoundland, who found that starvation-induced mortality associated with prey availability is an important component of natural mortality of northern cod. So, there's a lot of hypotheses that have been put out there in terms of the reason for cod collapse, whether or not, it's overfishing, whether or not it was a low productivity regime, whether or not seals. I think, it's probably a combination of all these factors, but there is evidence that, the prey availability was an important component of natural mortality of northern cod during this period. And so to bring it back to the seminar that Jeff gave to us, one point that he made is, we had this historical, very high abundance and biomass of cod. We've seen, through time, during the cod collapse, there has been slow recoveries of cod. However, we've seen the system shift to a more invertebrate-dominated system. So when we're thinking about how we manage these fisheries and ecosystems, a question that comes up is, what baseline is appropriate for fisheries management reference point? So is it appropriate that we should still be managing fisheries at, the level pre-cod collapse, or has the system shifted? And should we be thinking about where we set our baselines differently? So it's really this question that led us to host a workshop in 2021. This was a COVID workshop, so it was online. Here's a screen capture of some of the participants. Some of you may have been there as well. But we basically wanted to tackle this problem of how do we manage fisheries and how do we set reference points in highly dynamic ecosystems. We had keynotes by Andre Punt, by Robin Forrest, by Jason Link, and by Anna Rindorf, and lots of great discussion about, how do we tackle these systems that are in flux, such as what we see here in Newfoundland and Labrador. And as part of this workshop, we did a survey asking participants if they had provided dynamic reference points, the amount of experience that they had doing so, which is shown here on the panel on the left, and then some of the different fisheries that they had been provided for. So we see that Atlantic cod and snow crab and shrimp are among the species that, had been most highly referenced in terms of where dynamic reference points have been employed. We then asked, what are the different methods? How can we account for this dynamic nature of the system? And how do we include this into, the management stock assessment framework? And how often should these reference points change? So there's a number of different methods that had been used. So accounting for variable productivity, dynamic B0 or unfished biomass, which basically suggests that your present unfished biomass estimation might be different than it was historically. The use of ecosystem models, including dynamic stock recruitment, regime-based methods where we kind of look, at these different regimes through time and set the reference points accordingly. Allowing natural mortality to vary. So this could potentially be a way to bring this into stock assessment methods, or using a moving window where you might only look at what the baseline biomass was during, a 20 or 30 year period, perhaps, versus the entire time series. And then when asked, when or how often should reference points change, the most common answer was with changes in the ecosystem. So this really suggests that we need to be keeping track of when the ecosystem is changing in order to, make management decisions about, how we manage the resources within them. We also asked, what are the barriers to implementation of dynamic reference points? And this was kind of an interesting response. And it turned out that inertia was suggested as the biggest barrier to implementation of dynamic reference points. And this is inertia within the management system, such that, the stock assessment process has always done it in a certain way. So there's kind of this inertia that's keeping it going in that way rather than, perhaps changing to a different methodology. There's also a lot of responses that suggested if there's uncertainty if the change is lasting, if this is a dynamic system, how do we know if it's, going to stay in this alternate regime? Difficulty to operationalize. Again, this comes down to measuring whether or not the ecosystem productivity has changed or not. Lack of consistent methods, data limitations, lack of stakeholder acceptance. So really we see that there are a lot of reasons perhaps why we don't take these more dynamic approaches. And you could also imagine that if you are from an industry perspective, you don't necessarily want these reference points changing all over the place. You want to be able to plan for the future in order to know what to expect in terms of how much fish you're going to be able to harvest. And this sort of speaks to this broader approach of ecosystem-based fisheries management, of trying to understand how the ecosystem is changing through time, how the productivity regimes are changing through time, and how do we manage fisheries accordingly. So with one of my PhD students, we did a review, given the widespread literature about ecosystem-based fisheries management, what are the most common approaches? And what are the key principles in terms of processes and outcomes? And the main finding from our review was that effective EBFM implementation and positive socio-ecological outcomes require the strategic use of multiple complementary approaches. So it's not kind of a one-size-fits-all sort of scenario. And depending on what your desired outcomes are, you might use a different range of approaches. So now we're going to think about this in the context of the single species stock assessment. That's kind of the traditional way of managing stocks. Typically, this is done by taking into account things that increase the fish stock population. Typically, this is measured as recruitment, as well as individual growth. And then also taking into account things that cause the stock to decline or decrease through time. So this is obviously fishing mortality, which is commonly estimated, as well as natural mortality. And natural mortality is an area where sometimes single species stock assessments get criticized because they often sort of assume that this is a non-varying parameter through time. So 0.2 is sort of the common parameter estimate for natural mortality, but we can imagine in a system that might be changing a lot through time that this might also be variable. So sort of a way that you can try to step from that single species approach to a more ecosystem-informed approach is by trying to include some of these other factors that might be influencing some of these key parameters that stock assessment models use. So we could think about different quantities that might be modifying natural mortality. That might be temperature or predation or competition, for example. We could also think about things that would be modifying the increases in fish stocks through time, and that might be prey availability. And these types of models, which sort of strategically try to pull in specific environmental or ecosystem considerations, are sometimes referred to as MICE models, or models of intermediate complexity. So they're not trying to represent the entire ecosystem, they're just trying to kind of target the main mechanisms that are affecting these kind of vital rates that stock assessment models are using. And so another one of my PhD students, Matt Robertson, has been kind of looking at two different flatfish species in this context. And we can look at yellowtail flounder and American plaice. We can see their biomass trajectories through time from the 60s up until present. We can see that they both collapsed during that groundfish collapse in the 90s. But then we can see very different trajectories post groundfish collapse. So we can see yellowtail flounder has recovered, whereas American plaice has stayed at relatively low levels. And Matt has explored some of the different mechanisms of why these species that are relatively similar in their ecology might be responding differently through time. So he's looked at the patterns of bottom water temperatures, and they've remained relatively consistent through time, where we see warmer waters along the edges of the Grand Banks. But we can see that in the 90s, we see this influence or influx of cold waters, and the minimum mean temperature was in 1991, and the maximum mean temperature was in 2011. And trying to understand, has this influenced the recovery potential of these different species? So if we look at the spatial distribution of yellowtail flounder through time, we can see that it contracted in the mid-90s, during this groundfish collapse. And soon after this contraction, we see a re-expansion of its distribution to its former range, which coincided with the recovery of the stock. So there's some spatial dynamics that are going on here. Just let that replay for you. However, if we look at American Place, historically, the largest centers of biomass were in the northern half of the Grand Banks, and the spatial distribution shifted in the 1990s. However, we've seen that since the shift, most of the biomass has been in the southern half of the Grand Banks, and we haven't seen that recolonization of its distribution in the more northern part of the Grand Banks. So single species models, have a hard time explaining these dynamics. And so we really want to see if we can try to bring in some of these environmental drivers into some of these single species stock assessment models. So this is a bit of work that's ongoing, that's testing models of increasing complexity to provide ecosystem-informed fisheries management advice, and basically comparing the single species dynamic, the traditional approach that includes fishing and recruitment as the primary drivers. Then a model of intermediate complexity that would perhaps include the influence of the environment on recruitment or natural mortality. And then perhaps whether or not there's some competition that's taking place between these species, and is the recovery of one species preventing the other species from recovering. And so now we can provide some ecosystem-informed fisheries management advice, where we have the two species, American Place in the left columns and yellowtail flounder on the right. And we can look at the traditional single species models, and then the best fitting models when we incorporate some of these environmental factors. And we can then look at how the trajectories of biomass have changed through time, how the estimations of fishing mortality have changed through time, and how the estimations of recruitment have changed through time, based on whether or not we're accounting for the environmental factors, or if we're just using the traditional single species approach. So you can kind of provide both of these to decision makers to take into account. We can also look at potential recoveries by climate regimes. Now that we've incorporated the influence of these environmental factors, we can say, how would yellowtail flounder have performed if we had warm conditions during the cod collapse? How would it have fared in cold conditions or in average conditions? So again, and this is compared to the observed biomass trajectory. So this provides some ecosystem-informed advice and what we can expect for recovery potentials of different species under different climate regimes. So one of the other traditional EBFM approaches are the more sort of classic ecosystem models, which sort of describe the ecosystem structure and function and energy flow throughout the entire system, which consider the influence of the environment, of feeding interactions, that can be used to run fishing or climate change scenarios, as well as used for management strategy evaluation. And perhaps we would want to answer a question of, are we transitioning from an invertebrate regime to a groundfish regime? And these are something that ecosystem models can use. We can use them on a more sort of a strategic scale. And so we've been doing some work looking to answer this question. This is work that Abe Solberg, who's the PhD student, is leading. So on the left, we can see the amount of regions in the Newfoundland and Labrador Shelf and Grand Banks region that are kind of characterized by either invertebrate-dominated systems in the purple, or in piscivore-dominated systems shown in orange. And so we're starting here in 1995. And so we can see a decline in the dominance of the invertebrate characterized clusters, and an increase in piscivorous clusters, suggesting that perhaps we are transitioning from this invertebrate dominated regime back to a more groundfish dominated regime. And we can really see this if you look at the maps shown here. starting in 1995 on the top left, where we see a lot of the Labrador Shelf region dominated by this invertebrate clusters. And as we move through time to the bottom right, we see that there's a greater dominance by the piscivorous groups shown in orange. So perhaps we are seeing this transition from the invertebrate dominated regime back to a more groundfish dominated regime. And then when we think about this in more of a food web context and a predator-prey context, we can look at the influence of predator and prey. So here we are looking at the relationship between cod and shrimp through time. And the green values mean that there's a positive association between the two of them in terms of their biomass. So that we can see through, the late 90s up until 2011, increases in shrimp biomass were also concurring with an increase in cod biomass. So we see that they're positively, associated with each other. We see that relationship change around 2012, where increases in cod biomass now have a negative impact on the biomass of shrimp. So perhaps there is this shift that has taken place, and we can characterize these predator-prey feeding relationships in these sort of more whole ecosystem food web models. So that is a lot of the work that we're doing right now, and we continue to do within our group. So we're developing an ecosystem model ensemble for the region. So for the Grand Banks, we're developing size-based models using the Miser package. We have the ecopath models that Alva Bundy and Jamie Tam have developed that we're spatially resolving as well as updating to more recent time periods. We have the MICE approach that I mentioned before, the model of intermediate complexity, and we're also using some species distribution modeling. For the Labrador Shelf, we're using both the Miser, the size-based, and ecopath approach. And then Andrea Brindan Buchholz is developing an initial ecopath model for the North Water Polynya in the Arctic. So we really, we're spending a lot of time and effort trying to build this model ensemble. This requires a lot of work to integrate information from the stock assessments, from the biomass surveys, from fisheries landings. But it allows you to compare models of varying structure and not just rely on one specific model philosophy versus another. These can be used to inform sustainable harvesting rates, to evaluate multi-species harvest control rules, to set dynamic reference points to account for changing system states, and to project fisheries productivity and ecosystem dynamics under climate change. And that would fall under the umbrella of the work that Heike mentioned earlier of FishMIP, which contributes to the IPCC. So that's really something that's exciting for me, is to try to build up this regional ensemble of these models that we can use to answer a number of these fisheries and climate change sustainability questions. So I'd just like to summarize. So Newfoundland and Labrador marine ecosystems are highly dynamic, with cold and warm periods occurring on decadal timescales that influence ecosystem productivity. Following the cod collapse, fisheries catches shifted to invertebrates. There's evidence that the ecosystem is shifting again as groundfish slowly recover. Ecosystem-based fisheries management and dynamic reference points can provide frameworks to manage highly variable ecosystems. And ecosystem-informed and ecosystem models are tools that account for climate, oceanography, and ecology in fisheries stock assessments and climate change projections. So I'd just like to acknowledge the team that is doing a lot of this work in terms of putting these models together. It's been really fun to work with everyone and to be able to, build the ensemble for the region and tackle some of these ecosystem-based fisheries management and dynamic reference points questions. We also work very closely with a lot of colleagues at DFO. So it's great for the students to kind of have an interaction to see, how these things may or may not be used within the management process. And just to bring it back to where we started, I'd just like to leave you with the last paragraph that Jeff wrote in that piece where he was talking about communicating science with respect to northern cod. And I won't read it for you. I'll let you read it to yourself as you imagine how Jeff would sound as he would, be speaking in the fifth floor biology seminar lounges. I'm sure many of us have heard him done before.